Hey everyone, welcome back to the channel. Today we're taking our chat system to the next level by giving it memory. By the end of this tutorial, your chat system won't just respond to inputs, it'll remember past interactions, creating a more personalized and human-like experience. We'll explore techniques for storing and retrieving chat history, so your system can recall user preferences, past questions, and important details. Imagine your chatbot remembering a user's favorite movie and referencing it in the future conversations. That's the experience we'll build today. By the end, you have a fully functional chat system in C# that not only communicates with the user but learns and remembers from past interactions. So let's get started. We'll first cover how to store relevant information, decide what to save, and wrap up with how to recall information when the user needs it. Let's dive in. We've already seen how we can remember the user's conversation by keeping a history, and every time the user asks a question, we record it and its response from the LLM for the next round. Currently, when the chat is over, we kill the application, we lose the history. To save the history of the chat and restart that conversation is easy. We just serialize the chat into JSON, then save it into a file, database, or a backend system of your choice. For this example, we've added the implementation of saving the chat to a file, and when the chat is restarted, we show the history. Let's review it. We've added a new method to our simple chat called selectHistory. Then we just check to see if we have any files. If there are no files, we just exit. Otherwise, we display the files and allow the user to select one or create a new chat. We've also updated the chat with a model method. When the user ends the chat, we provide them with an option to save the chat. We've also added two additional methods as stubs to take the user's input and determine if we should store it in memory or query the memory. We will add the implementation later on. So with this, we have the ability to continue a chat conversation. So we have some history, but we can't cross chats, meaning what is noted in one chat is not shared or known in others. Now let's take a look at our memory implementation. As you can see, we do not have any previous chats saved. We'll start our simple chat, ask if it remembers my name. As you can see, it does. There is no chat history. We have implemented the two methods for our memory, and that's how this works. Now let's take a look at how the implementation is implemented. The isIntentToStore method determines whether the user's input indicates an intent to store information in memory. Let's break it down step by step. The method takes several parameters: Ollama client, model name, chat request, and user input. These parameters are used to interact with the Ollama API and track the user's input and chat history. The method starts by getting an instance of the kernel memory by calling the getMemoryKernel method. The memory kernel is responsible for storing and retrieving information from memory. Next, the method retrieves the system chat messages from the chat request. A new intent chat request object is created, which is a modified version of the original chat request without the history. This modified request is used to check if the user's input indicates an intent to store information. The method checks if the user's input is empty or null. If it is, the method returns false, indicating that there is no intent to store information. The method reads the content of a file called one.intent.txt. This file contains a prompt that is used to generate response from the Ollama model. The intent prompt with user input variables created by concatenating the intent prompt with the user input. The combined prompt and user input is used to generate a response from the Ollama model. We then call the chat completion method with our modified chat request to Ollama API and retrieve a response. We extract the response to see if we have a valid JSON. If the JSON extraction is successful, the method deserializes JSON into a memory entity object. If the memory entity is null, it means that the JSON deserialization failed, so the method returns false. The method checks if the first tag is equal to no memory. If it is, it means that Ollama model determined that there is no need to store information in memory, so the method returns false. If the above conditions are not met, it means that the user's input indicates an intent to store information in memory. The method sets the memory entity timestamp property to the current UTC time. We then import the memory entity into kernel memory passing in memory entity context, and tags collection. This method stores the text in memory and returns a document ID. Finally, the method prints a successful message to the console and returns true, indicating that the intent to store information was detected and processed successfully. The isQuery4Memory method is responsible for checking if a user's input is a query that can be answered from the memory of the chat system. Let's review. As the previous method, it accepts parameters for the Ollama client, chat request, user input, and model name. These parameters are used to interact with the Ollama model and retrieve the memory answer. First, we get the kernel memory instance. Next, the method calls the askAsync method on the kernel memory object, passing in the user input parameter. This method sends the user's input to memory and retrieves a memory answer object. The method then checks if the memory answer is not null and if it has a result. If both conditions are true, it means that the memory has an answer for the user's query. If there is a valid memory answer, the method prints the answer. Finally, the method returns true to indicate that a memory answer was found. If the memory answer is null or has no result, the method returns false. This tutorial has shown how to effectively use kernel memory in a chat system to store and recall user-specific data. By focusing on plain text storage and intelligent tagging, you can create a chat system that feels personalized and responsive to user interactions. Feel free to apply these techniques to other aspects of your chat system, ensuring that it remains both powerful and easy to manage. Whether you're handling user preferences, personal details, or other key information, kernel memory provides a robust foundation for creating a more interactive and user-friendly experience. Thank you for joining us for this quick introduction to implementing memory to your chat system. Don't forget to like and subscribe for more content like this, and we'll see you on the next video.